There is a drip irrigation system sitting in a field in York, Nebraska that has been running for 39 years on its original line. No one replaced it. No one upgraded it. It just keeps working. And the total material cost to build a system based on the same principles is less than $9. That is not a typo. $9. Meanwhile, the commercial irrigation industry will charge you somewhere between $1,200 and $3,500 per acre to install a professional drip system, complete with proprietary emitters, branded fittings, pressure regulators, and a maintenance plan that generates recurring revenue for years. Today, you are going to learn exactly how to build a gravity-fed drip irrigation system for your raised bed or small garden plot using components you can find at any hardware store or probably already have in your garage. More importantly, you are going to learn the one simple step that turns a cheap weekend project into a system that lasts 2 decades or longer. And you are going to understand why the companies selling $1,000 setups have zero incentive to tell you any of this. Let us start with what drip irrigation actually does, because the science behind it is what makes this whole thing work, regardless of whether you spend $9 or $900. Drip irrigation delivers water directly to the root zone of your plants. Instead of spraying water into the air where half of it evaporates or runs off into areas where nothing is growing, drip puts it exactly where the plant can use it. The efficiency numbers are not even close. Flood irrigation, which is still how a shocking amount of commercial farming works, achieves somewhere between 40 and 60% application efficiency. That means up to 60% of the water never reaches the plant. Drip irrigation achieves 90 to 97% efficiency. Research out of MIT found that switching from flood to drip cuts total water use by up to 60%, while simultaneously boosting crop yields by 20 to 50%. You use dramatically less water and you grow more food. That is not a trade-off. That is a straight upgrade. And here is what matters for you as a home grower. You do not need expensive equipment to capture most of that benefit. Here is the full build, every single component. Your reservoir is a standard 5-gallon bucket. You probably already have one. If you do not, any hardware store sells them for $2 to $3. Your main line is half-inch polyethylene tubing. 25 feet of it costs $3 to $4 at a hardware store, and you can sometimes find it at dollar stores for even less. To connect the bucket to the tubing, you need a barbed adapter or a simple spigot fitting, which runs $1 to $2. Your emitters are punched holes made with a heated needle or a hot nail, spaced every 6 to 12 inches along the tubing. That costs nothing. To pin the tubing in place along your garden bed, you grab a pack of landscape staples, about $1 for 10 at a dollar store. And finally, your filter is an old t-shirt or a scrap of cloth placed inside the bucket over the outlet to catch sediment before it enters the line. Free. Add it all up, and you are looking at a total cost between $6.71 and $9. Depending on what you already have lying around. Now, the obvious question: can punched holes in a piece of tubing really work as well as manufactured emitters that cost 10 to 20 times more? The answer comes from peer-reviewed field trials conducted with smallholder farmers in developing regions. Researchers found that even crude punched hole emitters achieve 73 to 84% flow uniformity. That means the water distribution along your line is reasonably even from the first hole to the last. Is it perfect? No. Commercial pressure compensating emitters will give you tighter uniformity. But 73 to 84% is radically better than hand watering with a hose, where you are flooding one end and barely dampening the other. It is better than sprinklers that lose half their output to wind and evaporation. For a home garden, for raised beds, for the vast majority of what backyard growers are doing, that level of uniformity is more than enough to grow healthy, productive plants. But there is a catch, and this is the part that turns a cheap project into something that actually lasts. If you build this system and leave the tubing sitting on top of your soil in direct sunlight, you will get maybe 7 to 10 years out of it before UV radiation makes the polyethylene brittle and cracked. That sounds decent, but it is nowhere near the potential lifespan of this material. The number one killer of polyethylene tubing is not water pressure, not mineral buildup, not root intrusion. It is sunlight. UV radiation breaks down the polymer chains in the plastic and eventually the tubing fails. And this is where the 20-year secret comes in. Bury it. That is it. Bury the tubing just 2 to 4 inches under mulch or soil, and you eliminate UV degradation almost entirely. Subsurface drip irrigation systems in university research trials have lasted 15 to 27 years with minimal maintenance. A Kansas State University study documented a subsurface drip system that ran for 27 consecutive growing seasons without replacing the drip line. When researchers excavated it and tested the flow rates, the system was still performing within 5% of its original output. The uniformity coefficient was approximately 98%. That is nearly factory new performance after 27 years underground. And that system in York, Nebraska? 39 years and counting on its original line. This one step, burying your tubing a few inches under mulch or soil, is the difference between a system you replace every few years and a system you never replace at all. Let us talk about the physics for a moment, because understanding how gravity-fed pressure works will help you set this up correctly on the first try. Every 1 foot of elevation on your bucket equals 0.43 pounds per square inch of water pressure. So if you set your bucket on a stand 4 feet high, a table, a stack of cinder blocks, or whatever you have, you get approximately 1.7 pounds per square inch. That does not sound like much, and compared to your household water pressure, it is not. But for a short gravity-fed line with simple punched hole emitters, it is enough. The water does not need to blast out of the holes, it needs to seep. Drip irrigation is slow by design. A single emitter might put out half a gallon per hour. That slow, steady delivery is exactly what plant roots want. No pump required, no electricity, no timer unless you decide to add one later. Just gravity doing the work, silently, for free, every single day. Maintenance on this system is so minimal it almost feels like cheating. Once or twice a season, you pull the end cap off your tubing and let water flush through for about 60 seconds. That clears out any sediment or biofilm that is built up inside the line. Once a year, if you have hard water, you run a 50-50 solution of white vinegar and water through the system. The vinegar dissolves mineral deposits that can slowly narrow the emitter holes over time. And every few weeks, you rinse or replace the cloth filter inside your bucket. That one habit alone prevents 90% of clogging issues. No replacement parts, no service calls, no subscription to some maintenance plan. 3 simple habits, and the system keeps running year after year after year. So why does the commercial irrigation industry charge what it charges? Follow the money. The drip system itself, the tubing and the holes, is the cheap part. The margin is in everything around it. Proprietary emitters that only fit specific tubing, pressure regulators, electronic timers, branded connectors and fittings that lock you into one manufacturer's ecosystem. Replacement parts for all of the above. A punched hole, gravity-fed system bypasses every single one of those products. A peer-reviewed study looking at low-cost drip systems designed for developing world farmers found that the approach reduced the cost of drip irrigation by 90%, from approximately $1,000 per acre down to $100 per acre. The method replaced manufactured emitters with simple punched holes and made the dripper lines movable so farmers could reposition them as needed. Farmers using these systems reported cutting their labor in half and doubling the area they could irrigate with the same water. The commercial irrigation industry generates billions in recurring revenue from replacement parts, proprietary fittings, and professional installation services. A system that costs $9 and lasts 2 decades generates exactly 0 recurring revenue. There is no mystery about why this information does not show up in the marketing materials. Now, if you want to take your $9 system and make it even better without breaking the bank, there are a few cheap upgrades worth mentioning. A $5 battery-powered timer on your spigot or bucket outlet automates the entire watering schedule. You set it and forget it. A rain barrel replacing the bucket means free water collection on every refill, and rain barrels can often be found for free or next to nothing through municipal programs. A $3 inline mesh filter, the kind you can find in the irrigation aisle at any garden center, extends emitter life and reduces how often you need to flush the lines. And if you have a larger garden, you simply daisy-chain multiple bucket and line setups together. Each one covers a bed or a row. Even with every single upgrade stacked on top of each other, you are still under $25 total. Compare that to the $1,200 professional installation quote, and the math speaks for itself. Here is what it comes down to. You do not need a $3,000 per acre system to grow food efficiently. The peer-reviewed science confirms the efficiency of drip irrigation at every price point, from university research stations down to hand-punched tubing in a backyard garden. The 27-year-old system in Kansas proves the longevity. The 39-year-old system in Nebraska proves it can last even longer. Every component is available at a hardware store or already sitting in your garage right now. $9 a Saturday afternoon and a hot nail. That is the entire barrier between you and a professional-grade irrigation system that waters your garden more efficiently than most commercial farms manage, with equipment costing hundreds of times more. The only thing that was ever standing between home growers and this kind of setup was the knowledge that it could be done this cheaply. Now you have that knowledge. So the next time you look at your garden and think about dragging the hose out again, or the next time you see a drip irrigation kit on a shelf for $60 or $80, remember what a 5-gallon bucket and $4 worth of tubing can do when you understand the science behind it. Try it on one bed this season. See what happens. And if it works the way the research says it will, tell another gardener. That is how useful information is supposed to spread.